We are going to do the section called Understand Rational and Irrational Numbers today. So a rational number is a number that can be written as a quotient of two integers. So examples would be fractions, decimals, whole numbers. The quotient is an answer to a division problem. So that's where you have your fraction. If you have 2/3, that really means 2 divided by 3. So 2/3 would then fall under the rational number category because it has a quotient. Integers are positive and negative whole numbers. You can write every integer, whole number, and natural number as a fraction. So for example, 3 is really 3/1. So you could take that, any whole number, put a 1 under it, and you have a fraction. The square root of 25 can simplify down to 5. 5 can be written as a fraction, so 5/1. So that would qualify under the rational number category. And then -5 would be the same thing. You just put a 1 underneath it, and it's now a fraction. So it is a rational number. It can be written as a quotient of two integers. This chart here I have printed out for you if you are in class. And it just talks about the different types of numbers. So the whole chart is real numbers. And then on the left-hand side, we have rational numbers. Rational numbers are the fractions, the decimals. They also include the integers and whole numbers. And integers are your positive and negative whole numbers. And then whole numbers are just regular counting numbers, positive whole numbers, including 0. So if I asked you to classify the number 5, 5 would fit into the whole number category, and that whole numbers is also inside of integers, and integers is inside of rational numbers, and rational numbers is inside of the real number chart. So a lot's going on that side. But on the right-hand side, we just have irrational numbers, and irrational numbers are the numbers that go on forever but never repeat. So if we gave you the square root of 17, you would do that. If you used a calculator, you would get this long decimal that keeps going on forever. But if I gave you the square root of 36, that would be 6. So that would actually fall over into the whole number category. So you have to be careful on the square roots. You have to see if you can simplify them first. Another example of irrational numbers would be pi. It continues on forever but never repeats. And those irrational numbers also fit into the real number category because this whole chart is all real numbers. So every terminating decimal is a rational number, which means it can be written as a fraction. So if I gave you 0.4, that's really 4/10, so 4/10, and that reduces to 2/5. 0.75 would be 75/100, so that would be 75/100, which simplifies down to 3/4. And then the square root of 25/100 would be 0.5, which is 5/10. And that's 5/10, which reduces to 1/2. So if it's something that fits over into the rational category, we can always write it as a fraction. Every repeating decimal is also a rational number, and repeating decimals are all rational numbers. So if we took 0.3 repeating and we needed to write that as a fraction, we would take the x equals 0.3 repeating, and then we would have to times everything, times both sides by 10. So multiply by 10. So that's where we get 10x equals 3.3 repeating. Then you're going to subtract x from the left and 0.3 repeating from the right. So that would leave you 10x minus 1x would leave you with 9x, and 3.3 repeating minus the 0.3 repeating would just leave you with 3. So every time you do one of these, you're always going to take 1x off of the left-hand side, and you're going to take the repeating decimal off of the right-hand side. And then you're going to do the upside-down t problem. So in this one, I'd have to divide by 9 on both sides, and I would end up with 3/9, which reduces to my answer of 1/3. So 0.3 repeating is 1/3 as a fraction. So for last example here, I want you to try 512 thousandths repeating. So we would start off by writing x equals 0.512 repeating. Then we're going to times both sides by 1,000 this time because tenths, hundredths, thousandths. That 2 is in the thousandths place. So we're going to have 1,000x equals 5.12.512 repeating. Then we're going to take off 1x from the 1,000x, so we're going to have 999x left. And we're going to take off that 0.512 repeating, so we're just going to have 512 left. And then we're going to divide both sides by that 999. So we have x equals 512 over 999.